As next, we will define our frame or workpiece. This is, in my case, this is this wooden plate which I already fixed on this desk with a double-sided tape in the middle, that the position, so I can't move it anymore, it is fixed in front of the robot, so we can reference anytime to this wooden plate. Okay, how it is done? I recommend you the same method. So we just prepared an origin, an X, and a Y. And there you can really see some mechanical holes on these positions. Why we are doing it so? It's quite easy because in the holes you can put the tip of the pen quite exactly, so it's won't coming away. And later on you will see that we can use some other supporting tools at these positions with manual tools where we do not have this kind of tip. This is the reason behind. So how do we define this reference frame in our RoboDK file? So we just select the frame 2 in this case, and we just hit define reference frame. For sure you could use the same here in the utilities menu. So add reference, no, not add, but define reference frame. However, first I will activate this. So this is the active frame, okay? Define reference frame. So the reference frame is the frame 2 in this case. The standard value in RoboDK for reference frame definition is this 3 point. Because most of the industrial parts, they don't have a corner, sharp corner, but they have a radius. In our case, we have a corner with our origin, so please use this. This is the most easiest one. Make it sure that the joints is selected instead of the points or poses. Okay, the right robot. And if not the tool one would be the active one here, this is very important that you check out the tool as well. Then you should come to the tool and you should hit activate tool again. I don't do this because, okay, right now you can see this is not the active one. I just hit it, activate tool, there's the check mark next to, and then you can really make it sure that the reference frame is referencing with the correct tool, which we just defined on the TCP. So the procedure is a very, very similar to the one which we already done with the tool. I just come into the free ride mode and I just try to navigate to the origin. And right now I just switch to the jog. And in this case, as any calibration process in live, you should really take care about that you can hit it as accurate as it possible, okay? So for me, it looks pretty cool. So I just switch back to the remote mode on the teach panel. I just hit get position, so you could see the robot was moved along. And this is my P1, BAM. Okay, right now we have to go to the x-axis. This is very important. This is our x point, okay? So you really have to take care about that. This is the x, this is the y-axis, okay? So I am just coming over in the free ride mode to this x reference point and just coming back to the jog as usual. Okay guys, so this should be quite precise, and then we are just switching back to the remote mode. I'm hitting the get position. You could see that the robot was changing the position on the screen. I'm just get the P2. And I usually go to the Y directly. So you could use at this point anything on the surface. You can see that the P3, this must not be at this point. I'm using this one because I have the best results, or I'm get used to do this. With this one, I can make it sure that even at this point, the Z, the height is a good one. So I'm just hitting the get position, bam. And then I just hit it. And you should see on the screen that the reference frame coordinate system will move here. Yeah? So this is the one. So it was so easy. I can close this and just drive back to a neutral position. And that's all. We already defined the reference frame, the working area where the robot will work later on. Okay? I just hit save and we are ready.